Is a follow-up video as promised, which is basically an explanation of why the spectrum analyzer is not fixed. There's not going to be much demo in this video, just basically explanations. If you all recall, if you look at the first video, the hypothesis was that one of the IF bandpass filters was bad, which I widened out each filter by grounding one of the test pins, which essentially widens out the filter to the highest bandwidth, which is 5 megahertz. And I noticed that upon doing that, the amplitude jumped, whereas under normal operation, the amplitude at 100,000 kilohertz dropped 14 or so dB, which was too much. You can see this in the original video where I'm demonstrating the noise floor. Anyway, that's the oscilloscope I fixed right there. Just wanted to get that in. So nonetheless, what I did was I tweaked. Let me reverse here. When you're adjusting the IF bandpass filters, you're supposed to widen out 3 of the 4 filters. There's 4 LC filters and 4 crystal filters. You're supposed to widen out or basically bypass 3 of the 4 filters, and then the one which is not bypass, you calibrate it, you adjust it. One of the adjustments is you're supposed to adjust it to its lowest level. Now, obviously, the 100 kilohertz bandpass filter, its lowest level was too low. So what I did was I basically hacked it. I adjusted it to where I raised its level rather than lowering it to the lowest amplitude, which is against what the instructions are on how to calibrate it properly. Now, what this did was offset the error that was inherent in the circuitry of what is wrong with the circuitry. I have the circuitry here on my monitor. You can take a look at it. Let me move over to where it is. I think this is what's wrong. This is the second LC pole. I think it's either that transistor or that pin diode. I've ordered some parts and I'm going to do some further investigation. The point is to fix it properly, the fault has to be isolated, and it has to be adjusted to within proper tolerances. And I'll show you what I mean. We'll power on the analyzer and show you how it's calibrated. You can actually display the calibration constants. So we'll let it boot up. We'll do the preset here. So it'll only take a second. Boots up pretty quick. And if we go to calibrate, and then we go to the service menu, service diagnostic, we can display the calibration constants. Now, I don't know if you can see that or not. I'll try to hold it steady. That one column, which basically says BW amp, that's bandwidth amp, that is a offset calibration constant or coefficient if you want to use mathematical terms. Now, I don't know if you can see that or not. Each one of those figures, not the top figures, but towards the bottom, each one of those represents a offset coefficient for the bandpass filters at a certain bandpass frequency. Those, to be correct, should not be any more than negative 0.8 dB and between negative 0.8 dB and positive 0.5. That's normally where they should be. Now, if you look at where these are, we have some at 1.37, 1.46, and even one as high as 2, which means that basically the calibration routines are working extra hard to just basically force this analyzer into calibration. And it works. I mean, and it is within calibration. It works nicely, in fact, but it's not right. It's not right. So I have to find out what's wrong with this. and fix it. And that'll be related to the other videos in this series. Also, wanted to update on the DAC tests. I told you all that I would be doing the DAC tests to test the voltages, and this is the results. If you look down here, these are the proper voltages for this series board. I did find an anomaly. All of these figures were exactly correct except for BW5. BW5, the plus 14 figures were correct. But when it switched from the LC filters to the crystal filters, instead of negative 0.5, I got negative 1.2, or somewhere in that area, very close to that approximately. Now, either something is wrong with the analog interface, which I really don't think that that's true. I managed to dig up some other schematics where the other figures are not correct, but the BW5 figures do alternate between 14 and negative 1.2. And when you take that into consideration, and you take into consideration that I have checked everything, and it does look like it's correct, like it is adjusting correctly. Also, the plus 14 figure is correct. So if there was a problem with the DAC, if there was a problem with the transistor, that it simply was putting out too much voltage, you would think the offset would be across the board, and it's not. All the other figures are perfect. It's not definitive, but I think what has happened, and HP does this a lot, I think that probably I have another revision of the board, and the voltages are changed. I have quite a few different schematics for different versions of this board, and the voltages are different on each one. So that's the hypothesis for right now, but I do wish that it was, negative 0.5, but it is negative 0.12. And if any of you want to leave a comment and tell me, if you know for sure that it's right or wrong, I would like to know. This is the version of the board that I'm using. This is the board. 8590 60158, I guess revision 1. Again, I think it's operating properly as far as the analog interface is concerned. You would see some kind of change across the board, I think, if it wasn't. So the next plan is to investigate, buy some parts, and try to figure out what's wrong with these filters and go from there. So right now, the culprit seems to be this guy right here, which, by the way, is on the A13 board, not the A11 board. And it's test pin 6. And it's the second filter pole of the LC filters. As you can tell, right there, second LC pole. So, okay, hope this has been informative, and I will be back with another one. Thank you.